All right, well, I hope this is on, and good morning, good afternoon, good evening, whenever you guys are watching this video. We're going to be talking about three new theorems today, Theorem 615, 616, and then Theorem 617. And so to get started here today, Theorem 615, all three of these theorems are real short and hopefully pretty simple theorems for you. So the very first one, I'm going to write down the beginning part of it, the base angles. Okay, and again, I would underline that because that's what the focus of the theorem is on, of an isosceles trapezoid are what? Okay, we're going to be looking at the base angles of an isosceles trapezoid, and again, I've told you guys throughout the year that there are certain theorems that you forget. Okay, they're so simple you just kind of you kind of forget them, and we don't use them that often. But this is one of those theorems I would warn you of. Don't forget this theorem right here. So I'm going to go ahead and draw an isosceles trapezoid here real quickly, and hopefully you remember the characteristics of the isosceles trapezoid, being that a trapezoid, we have exactly one pair of parallel sides. Okay, so keep that in mind. And we also have exactly one pair of congruent sides, but they're the non-parallel sides. Okay? And so, first of all, the structure of the trapezoid is like this. The two sides that are parallel, we always refer to them as the bases. So here's a base, and here's a base. Okay? And the two non-parallel sides, we refer to them as the legs. So here's a leg, and here's a leg. Okay? So that's the structure of an isosceles trapezoid. Now the question here is this, and I know I didn't draw my picture real accurately, but I think you can probably look up here and see it. The base angles, okay, the two angles along the same base, these two here, and the two angles along the other base, these two here, have a relationship, and the question is, what's that relationship? Okay? Now, in order, I have no idea why that just popped up, so I apologize about that. In order to understand that, I'm going to take us back to something we've talked about earlier on this year, and that's an isosceles triangle. Okay? We're talking about an isosceles trapezoid. Why don't we talk about an isosceles triangle? And if you remember, not only are the two sides congruent, but those sides here and here influences the angles opposite. So if I go to the opposite angle here, boom, and boom, okay, we can see that they're congruent. Now, the question I would have for you guys is this. If I cut off the top of this trapezoid, right there, okay, I can move that line up or down from where it is, but let's say it's right there. Have I changed these angles in any way? And the answer is no. They still remain congruent. And so if you can picture to yourself these two lines being parallel to each other, those two angles will always be congruent. So if I move over to my picture over here, this angle will always be congruent to that angle. Now, something else I want you to understand or think about for a second is this. Let's assume for a second that this is 70 degrees. Okay, just pulling a random degree measurement out of the air. What would the measure of this angle have to be? And I'd hope that you guys, we've done this enough this year, that with parallel lines, these same side and interior angles along the same transversal, these same side and interior angles have to be supplementary. So 180 minus 70 gives us 110. Okay? Well, if I come over here, we know that this is also 70. So 180 minus 70 is still 110. So what I also want you to see is that these angles also, being along the same base, are going to be congruent. So whenever you have an isosceles trapezoid, the base angles will always be the same measure every single time. Okay? Now, Theorem 616 looks like this. Clear that. Okay, so Theorem 616 looks like this. The diagonals of an isosceles trapezoid are what? Okay. So the first thing I want to do, I'm going to go ahead and draw an isosceles trapezoid here. Hopefully. Maybe. There we go. Using this new marking tool isn't always the easiest. Okay, isosceles trapezoid, A, B, C, and D. Okay, and here's what I want you to look at. Now, we're going to compare BD and CA, okay? And in order to do that, I'm going to go ahead and redraw those two triangles separate of each other. So if I draw the two triangles I was referring to would be ABD, okay, and DCA. All right, and I'm going to mark AB congruent to CD because that was already marked out within the picture there. Okay. Now, what else do we know about those two triangles? Well, AD is congruent to AD. I think most of you have caught on to that concept really well, so I'm going to put that there. And we also just said that this angle right here is congruent to this angle over here. Okay. They're the base angles of that isosceles trapezoid. So I'm going to go ahead and mark those two angles congruent to each other. So what we have would be two triangles that are congruent by side, angle, side. Now, if they're congruent by side, angle, side, we then would know that this side length here is congruent to this side length here by CP, CTC. What does that mean? Well, that means that the diagonals CD and CA and BD will be congruent to each other. So the diagonals are always congruent within an isosceles trapezoid. Okay, another one of those theorems that I think we oftentimes will forget throughout the year. So put that away in your memory banks. Now, what I want to make sure you understand is, what other object have we talked about this year that also has congruent diagonals? Well, that would be the rectangle, right? Okay, so the rectangle has congruent diagonals, so does the isosceles trapezoid. What's the difference? Well, one's a parallelogram and one isn't. And so you need to keep that in mind as we move forward from here. The last theorem that we're going to look at is theorem 617. And theorem 617 says this: the diagonals of a kite, okay, working with a kite this time, are what? Okay, are what to each other? Well, here's what we're going to do. I'm going to go ahead and draw a kite. Now remember the definition of a kite. First of all, this is not a parallelogram. Okay? And we said that the definition of a kite was there are two consecutive sides that are congruent and the opposite sides are not congruent. So if I connect the diagonals here, okay, there we go. Okay. Now, obviously, I hope that you can look up there and think, after what we've talked about the last couple minutes, congruent doesn't pop in your mind. If you look at BD and AC, congruency isn't an option, and it's not going to be for a kite. But in order to understand what I want you to understand about the kite, I'm going to go ahead and redraw the two triangles ABD and CBD. Okay, and I'll remark them accordingly to what we have over there in the other picture. Oop, I had no idea why that just moved like that. Technology is great. Anyways, what I want you to see is that these two triangles are congruent by side, side, side. And if that's the case, then this angle here is the same as this angle here, and this angle here is the same as that angle there. So I'm actually going to go ahead and put that down over here within this picture right here. Okay? Now, why is that important to know? Well, the reason is, if you compare these two triangles, and I were to ask you, how do we know that those two triangles are congruent? I would hope that you would say by side, angle, side. Okay? Well, if they're congruent, that means that this angle here is congruent to this angle here. And together they form a straight line. So if they're 180 degrees, both of the same measure, I can go ahead and put 90 degrees right there. Maybe. There you go. Okay? Now, I could also go down here and ask the same question with these two triangles. We know that these two are congruent by side, angle, side. Again, these two are congruent and they correspond. So as a result, since their sum is 180, each one is going to be 90 degrees. Okay? So what have we discovered? We've discovered that the diagonals of a kite are going to be perpendicular. Okay? And you're going to use those three concepts in the example problems that I gave you guys to work out. And so if I go ahead and take a look at, let's see here, clear that off. Let's close that. Get this guy to come. Can I get this guy to come up now? There we go. Okay. You can go ahead and fill in those three blanks right there, which is what we just got done talking about. And let's take a look at this first picture. It says complete the drawing. Now, the reason why I want you to complete the drawing so that you know your way all the way around a kite. And so the first thing I'm going to do is I'm going to put in the right angle symbol, knowing that all four of those angles are going to be right angles right there. I also want to go ahead and put in the fact that this is an isosceles triangle, so I know that this angle will be congruent to this angle. If I look at the other big triangle, I can go ahead and say that this angle is congruent to this angle again because it's an isosceles triangle. And then if you remember, when we looked at the big triangles, in this case it would be ABC and ADC, they're congruent by side, 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 and then the reflexive property, side. So I know that this angle here will correspond with this one here, and this angle here corresponds with this one here. Okay? So there's no reason we can't know all the angles within a kite with a certain amount of information that's given. Now, I want you to drop down to number 1 with me real quickly here. I want to make sure that we've got this down from what we talked about earlier. And here's what you should probably do. Make sure that you've identified where your bases are. Do the bases always have to be on top and bottom? No. In fact, you're going to see some examples here in a little bit where they can be on the left and right. And so knowing that those are my bases, I know that this angle and this angle have to be the same measure because they lie along the same base. Okay? So 102 is going to be angle C. All right. We also know that same side interior angles are supplementary. We've talked about this just a couple minutes ago. Same side interior angles are supplementary. So these are the same. And if we take 180 minus 102, you get 78 degrees. And you can go ahead and write that down as the measure of those angles there. Okay? So again, that's within an isosceles trapezoid. If it's outside of an isosceles trapezoid, you cannot use that theorem. Okay? So let's go down to number 3 now. Want to work this one with you. If we look at number 3, knowing that it's a kite, the very first thing I'm probably going to do is to show that the diagonals are perpendicular. So if I go ahead and do that, show that those are right angles right there, I know that angle 1 has to be 90. Okay? The most easy thing that you can do within a kite is to identify that angle measurement there. Now, from here, I know that, well, let's do angle 2 first of all. If this is 90 and this is 32, angle 2, 180 minus 90 minus the 32, okay, which is going to end up being 58 degrees. So that's going to be angle 2 for you. Okay. Now, angle 3, we actually can go ahead and you can do several different things. You can play around with the big triangles as far as being congruent by side, 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 side. You could also take a look at these two small triangles, and the way I've marked them out, we know that they would be congruent by a hypotenuse leg. Hopefully you guys remember that, that last way to prove triangles congruent, hypotenuse leg. Either way, you know that the corresponding angles here and here will have to be congruent to each other. So I'm going to put angle 3 will be 32 degrees. Okay? So again, just working your way around the kite there. Now there's just a couple of other example problems I want to make sure that you see. The first one being number 5 right here. I told you that the bases of an isosceles trapezoid don't have to be on the top and bottom. They can be on the left and right. So again, I'm going to identify the base here and the base here. Okay? Now remember, the angles along the same base have the same measure. So this angle here, 62, will be the same as angle 2. Okay, so we know angle 2 is 62 degrees. From there, here's my transversal. These two angles are same side and here. So angle 1 will be 180 minus 62, which is 118 degrees. And now you've found both angles 1 and 2. Okay, so just something to think about. Let's go ahead and flip over to the back side of your worksheet. And as we look at number 13, we know that number 13 is a kite, okay? But the question is how do we find angles 1 and 2? And there's actually 2 different ways you can do this. As I said before, you can go ahead and drop a line down between those two. Man, that's an awful line. I apologize about that. This pen is hard to draw with. Anyways, that line right there, drop down between those two, splits the two triangles into two congruent triangles by side, side, side. And if those triangles are congruent to each other by side, 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 then we can go ahead and do 2 things. Is it going to be any better? A little bit better. Okay. We can say, I have no idea why that disappeared. Okay. We can say that since these triangles are congruent by side, 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 that the whole, let me just mark this out, that this angle here will be congruent to this angle here. They correspond to each other. So in order to figure out what the measure of angles 1 and 2 are going to be, like I said, there's 2 different things you can do. You can go ahead and do either 360, the sum of all those angles within that quadrilateral, minus 101, minus 48. So we're subtracting out everything that we have, and then dividing that difference by 2 because both angles are the same measure. Okay? And that will give you the measures of angles 1 and 2. You could also, since both of these angles are congruent to each other, we can go ahead and say that this is 24 degrees and that this one up here is 50.5 degrees or 50.5 degrees. And then you can go ahead and take 180 minus 50.5 minus 24, and you will get the exact same answer for both of those. In both situations, angles 1 and 2 will both be 105.5 degrees. Okay? So, 2 different ways you could go ahead and solve that one there. Either one of them is correct. For the last problem I want to look at with you guys, looking at number 14 just to make sure we have this down. If I go ahead and look at number 14, here's what we have. Angle 1 is pointing to the angle formed by the 2 diagonals. So again, I would always start with the fact that diagonals are perpendicular within a kite. So angle 1 will be 90 degrees. Okay? Angle 2 gets pretty simple after that's been identified. You can go ahead and take 180 minus 90 minus 65, and you end up with 25 degrees as the measure of angle 2. Okay? All right, the reason why I paused there was because I wanted to double check and make sure. I wanted to do one of these last ones with you because you're going to be doing a couple of example problems for me to make sure that you've got this down. So I'm going to do number 20 with you guys, and here's what I want you to see. We know that the diagonals are perpendicular within a kite, and I'm still starting with that concept before I do anything else. That's how I'm going to start to problem solve here. So I'm putting things down that I know to be true. From there, you can go ahead and say that these two triangles at the very top, this one and this one, are congruent by a hypotenuse leg, okay? Now, the reason why that's important, and I'm sure you could see this before, but I'm just giving a reason why it's true. This angle right here is congruent to this angle here, and that's important if we're going to go ahead and solve for x, okay? And so there's several different equations you could probably set up here. The one I'm going to use is going to be 90 plus 5x minus 1 plus 8x is equal to 180. Okay? Now I know you guys can go ahead and solve that. I just wanted to make sure that you saw that so that you could know how to at least do number 19. And I think based off what we did up in number 13, you can probably figure out what to do with number 21. Okay? So here are the problems I'd like you to finish up for me. I'd like you to do numbers 6 and 7 from the front side. And I'd like you to do numbers 12, 19, and 21 from the back side. Okay? And again, don't forget that the homework that's aligned, this is just in-class work, so I know that you guys got what we did today. So again, thanks for being an attentive audience. Yeah, good night.